In this video, we're going to show the Gravograph model M40 ABC computerized engraver and how we adjust the cutting bits to work on the machine. To do that, we're going to first have a cutting tool, the carbide tip. The label on the top tells us the size of the engraving tool. It says it's a .030 tip size, and the GPY means it's for Gravoply or plastic. First thing we do is take a look at the machine spindle and understand how the machine operates. Lift this cover up, and if we push up on the spindle, we can see it moves up and down. You push it up, spring pressure forces it down. This little lever here, graduated 1, 2, 3, 4, is how much pressure is pushing down under the spring load. The best setting is probably a 2 for engraving in plastic. At the bottom of the spindle here is a micrometer dial. This is a locking screw. The micrometer dial is used for regulating the depth. The first step is to reference the tool to the engraving machine so that it will be corresponding to what the dial says how deep the engraving will be. To do that, we take the engraving tool and we loosen the cutter knob with a special spline wrench, and I like to turn it upside down so that it will act as a depth stop with a little bit less vibration. It drops through the top of the spindle. Then you'll notice that it slides up and down. The micrometer dial should be set on 0, and it goes around and around and around past 0 many times until it falls off the bottom. To pick a home 0, I screw it all the way up to the top, and then I reverse directions and come down to 0. I don't use the first 0, but I come down 2 more revolutions. That will be my home 0 position. And that's an arbitrary setting. It could be 2 or it could be 3. But 2 revolutions gives us 2 revolutions of depth that we can set on the machine. Each graduation mark from here to here and from here to here and so on will change the depth of engraving by 1/1000th of an inch. So to reference that, I take a name badge magnet and I stick it on the bottom of the vacuum nozzle. Then when I drop the tool down, it'll touch that magnet. And then up at the top, I can lock the cutting ring, the cutter head, so that if I ever take this tool out and put it back in, it will come to the same position. If you have multiple tools, it's a good idea to set them all at the same time so that they'll all be referenced to the machine. Now, the engraving plastic is laminated. The top color, you'll see that thin white line, is 0.010 of an inch thick on most of the plastic. On some plastic, it's only 0.002 thick, but for most, it's 10. If you can see it from the edge, it's 10. If you can't see it from the edge, it may only be 0.002 thick. So when we set our engraving depth, we wanted to set it on 15. So after we have set the tool to 0, and then we have to lock it in position so that it will engrave. Right here is a 2mm screw, different than the spline wrench so that you don't confuse them. We'll just tighten that 2-finger snug to hold it in place. Now we can take the magnet off, and measuring with the micrometer dial, we will move the micrometer dial up 5, 10, 15,000ths of an inch, or 15 marks. Excuse me. So now the tool is exposed at the bottom 15,000ths of an inch. And when we're engraving, this spring pressure will push the nose down against the plastic, which is held here in the vise. And that will then give us a consistent depth of 15,000ths of an inch. The vise has centering marks on it, so we center it up so that it's reading the same number on both sides, and we lock it in place. Now this is an adjustable stop here. It can be used so that you can put additional pieces in and just slide them to a stop. So to review, we set the micrometer dial on 0. That's 2 zeros down from the top. Put the magnet on the bottom, put the tool in and dropped it down till it touched the magnet, and then locked everything in place. Then we moved the dial from 0 up to 15 so that we can take this tool out, put it back in, or any other tool that was set at 0, and it will be exposed the correct depth at the bottom so that it's going to engrave a consistent depth. Now sometimes you want to use the machine for cutting out name badges. You put a big sheet of plastic on the flat table attachment, and then you can adjust the tools to cut out the nameplates. You can engrave a full sheet and then have it come back and cut them out. To set the tool for the cutout tool, we take our engraving tool, which is a special cutout tool, and we want it to work without having to make any changes here on the spindle. So when this dial is on 15, we want the cutout bit to cut almost all the way through this 1/16 inch plastic. Now if you look up on a decimal equivalent table, you'll find that 1/16 of an inch is 0.062, which is 62 thousandths. That's how thick the plastic is. So we want the cutting bit to be sticking out of the bottom of the nozzle about 60 thousandths. So to do that, we put our magnet back on the bottom of the nozzle. We drop our tool down till it touches. That's with the dial on 15 now. Now this is a tool that's going to be used for cutting out the plastic instead of engraving. And we want it to work when the dial's on 15 so we don't have to make any changes or adjustments. That way we only have one thing to remember. So starting at 15, if we want it to engrave 62 thousandths, our problem is, how do we know when that's sticking out the bottom 62 thousandths? Well, we have a micrometer dial right here, which is a precise measuring device. So what we do, starting at 15, we move the dial down 60 thousandths. So I'm going to come down, counting by fives. Each time I pass a number, it's 5 more. There's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And then I drop the tool down till it touches. Then I lock the brass knob in place at the top so that when I take it out and put it back in, it will be in the right position. And then I lock the tool in place. So now I've set it at 60 thousandths below the 15 mark. I'm done with this magnet. I can now move it back up 60 thousandths, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and I'm right back at 15 where I started. Now if you look at the bottom of the spindle, see if I can get down there. So you can zoom in a little bit. You'll see the tip of the tool sticking out the bottom of the nozzle, and it's sticking out almost enough to go all the way through the plastic, but not quite. And if we take our other engraving tool, which we set for doing the engraving, and put it back in, when the dial's on 15, it will only be sticking out 15 thousandths because it was set at 0 and then the dial was moved up to 15. That's the way we set the tools. Then at any time you can put any tool in the machine. If it's the cutout tool, it will be set for the correct depth for cutting out. If it's the engraving tool, it'll be set for the correct depth for engraving. Remember, when you put the tool in, tighten it with this 2mm Allen screw, just barely just barely snug, so that it will not slip. If you don't have to tighten it too tight, that way it will not put a dimple in the shaft and cause difficulty when you try and remember, or when you try and take it out. So the spring-loaded spindle will now push the nozzle against the plastic. The mount the tool is sticking out. The bottom of the nozzle will control the depth. If you want to go a little deeper, you just loosen this locking screw, move it up to 20. And the regular engraving tools will engrave 20 thousandths deep, but the cutout tool, which is in there now, is going to engrave 2 deep. It only works when the dial is on 15. So you only have to remember one thing: keep the dial on 15, and all the cutters will work if you set them up this way.